plastic properties or plasticity means once you change the configuration of the object, it is completely changed. You can never regain it back by its own. All of a sudden, although the complete superficial area starts compressing until certain volume. This volume, that is delta V, changes. That means it decreases. Even if you give a small amount of stress also, the strain is greater than the stress because the strain is permanent there. Hello everyone, I'm Vrinda from Department of Physics, welcoming you all to Chapter 9, and the chapter name is Mechanical Properties of Solids. In today's chapter, we are dealing with some of the properties of solids. So before that, first of all, you'll have to think what is meant by a solid. The solid is an object in which the molecules will be tightly packed. So the force of attraction between two molecules will be greater. That means it will have the intermolecular force of attraction between two of the molecules is very strong. So because of that, we call it as solids. That means it's a rigid body whose molecules are closely packed. So as you all know, we have studied this since our grade 6. So next we are going to deforming. What is meant by deforming? Why this concept has come? As you can see in this picture, here you can see a ball. That means which is said to be a solid. A solid, there is a force which is exerted. So this is the force which is exerted to a solid. So as you exert certain force, it gets deformed. So deforming means change in configuration when a force is applied. The change in its configuration when there is application of external force. So that is happening over here. So as you give an external force from external side, that is outside, what happens to the object? Object gets deformed. So the object gets deformed, and when you just remove it, again it comes back to its original position. Such kind of a force, as you exert the external force and the object is changing its shape and then getting back to its original position, is called as your deformation or deformed force. So what is meant by this elasticity? So there are two types of concepts here. One is elasticity we study, one property is plasticity. So elasticity means, as you can see here, there is a spring. That is, elasticity is the phenomenon where the object which changes its configuration at certain interval of time due to the application of force regains back to its original shape. So what exactly is elasticity? Elasticity means it's an elastic component. As you pull the elastic, there is a change in configuration. As you leave it, it comes back to its original position. The similar way, phenomenon where the object changes its configuration at certain interval of time due to the external force which is applied on it, and then finally it regains back. Such kind of a concept which is applied on any of the object is called as elastic. And you have some of the elastic objects, which you can take an example of spring itself as the one which gives you a elastic property. Next is plasticity. So plastic properties or plasticity means once you change the configuration of the object, it is completely changed. You can never regain it back by its own. Okay. Suppose, for example, if there is a pottery. Suppose if you give an external pressure or a force and change its configuration, what happens to it? Completely, all the configuration is permanently changed and we can't regain the same position back until and unless we give a shape in this. In a clay, suppose if a clay, when you purchase a clay, it will be neat and nice, correct? It will have a definite shape. Once you start using it, even if you want to get it to an original shape, you can't regain it back in that fine shape, correct? So that is the example of this plasticity. So plasticity is once the change in configuration happens, change in configuration, that is said to be permanent. It will not regain back to its original position or the original shape. Such kind of a concept is called as your plasticity. Next, we are going on to stress. So we got to know what is elasticity, we got to know what is plasticity. So we need to know what is a stress. Stress is nothing but the force. But how exactly? There is a specific way of defining what exactly is a force. Where do you apply a force? So, force is applied to certain object, not the complete object, but it is applied to certain area of the object. So, stress is nothing but the force which is applied per unit area. So, stress means the force applied per unit area of an object, whichever you consider. That is called as your stress. Next, we are going on to types of stress. So, under stress itself, we have too many types of stress, out of which we study all of these. What is this? One is a longitudinal stress, or it is also called as a normal stress, which is acting lengthwise. Another one is hydraulic stress, the one which is acting with respect to your complete area, that is the volume it considers. Next, it is tangential stress. In case of your tangential stress, tangentially the force will be acting on a object. Okay, so out of this normal stress or your longitudinal stress, it is being divided into tensile stress as well as compressive stress. Another one is tensile stress or compressive stress. So what is this? When a stress is being produced, the length of the body increasing, that is called as tensile stress. So when a stress is produced, the length of the body decreases, such kind of a stress is called as compressive stress. So let us just see what exactly is. Let us just define all of these stress. First of all, longitudinal stress or a normal stress, that means to say it is nothing but stress is usually given in terms of is equal to the force acting per unit area along its length. Okay, force acting per unit area on its length is called as your longitudinal stress or a normal stress. This is with respect to length. Okay, so lengthwise if we go, one is tensile stress and one is compressive stress. So tensile stress means there is increase in its length. Okay, change in length. So stress is force exerted per unit area such that there is a increase in length. Such kind of a stress is called as tensile stress. And compressive stress means there is decrease in its length when there is a stress which is exerted. So that is all about your types of stress, that is lengthwise the variations you have. So here, suppose if you consider a sphere and you exert certain external force from all the sides on the superficial layer of a sphere, all of a sudden the complete superficial area starts compressing until certain volume. This volume, that is delta V, changes. That means it decreases. Such kind of a force is called as hydraulic stress. Hydraulic stress means restoring force which is applied per unit area on a sphere or on an object is called as hydraulic stress. Similar way, we have got a tangential stress. Suppose if you have a body like this, which is fixed to a floor or fixed to a ground or a table, and we apply a force which is tangential to an object, it just bends from the fixed position for a certain angle. Such kind of a concept is called as tangential stress. So that is all about your longitudinal stress, or it is also called as normal stress. Hydraulic stress is also called as volume stress, and we have a tangential stress. So these are the types of stress that we had to study. So now coming on to the next concept, that is strain. So what is a strain? Strain is nothing but whenever you produce stress, the result of it is called as strain. So whenever stress is produced to an object, it undergoes strain. So strain is in what ways? So when you see that the resultant of stress is called as strain, means there has to be some change in its configuration. Change in its configuration. Maybe one is lengthwise, maybe volume wise, etc. Correct? So such kind of a concept is called as strain. So what is strain? Strain is nothing but change in its configuration. Configuration is nothing but the dimensions to its original configuration is known as strain. Change in its configuration to original configuration is known as strain. So types of strains are longitudinal strain, volume, or it is also called as bulk strain, or shearing or shear strain. When it comes to longitudinal strain, we have strain is nothing but change in length to its original length. When it comes to volume or bulk strain, it is change in volume to its original volume. When it is with respect to shear strain, it is with change in area to the original area. So shearing strain or a shear strain means it is relative displacement. It's a relative displacement of one plane with respect to the fixed plane. That is called as your shearing or shear strain. So that's all about your types of strain here. So we studied about stress, types of stress, strain, as well as types of strain. So along with that, we have something called as Hooke's law. That means a body which is at rest or in equilibrium position, when a load is applied to the same object, there undergoes extension. And this extension is due to the stress which is applied, so that as a result you can see the strain here. So what is a Hooke's law? So Hooke's law is nothing but the ratio of stress to the strain. This is called as Hooke's law. The ratio of stress to strain is called as Hooke's law. In this case, what is the thing what is applied to this spring? That is, the force is applied. Force is directly proportional to the displacement. How much of a force you apply, so much of displacement can be seen. How much of a force you apply, so much of displacement you can see. So F is equal to minus K of X. Why this minus negative sign? Because it tends back. So once you pull the spring, as you leave it, it gets back to its equilibrium position. That is why the negative oscillation is called as negative over here. So force is equal to minus K into X is what we get. That is called as your Hooke's law. So this equation is all about how this spring works for the spring constant. Next is stress strain curve. With respect to stress strain curve, we can see here, we can see Hooke's law. A to B, it's an elastic region. B to C, B to E, it is a plastic region. That means from here to here, that is the elastic region, is the region till where exactly we can extend the limit of that spring or any of the object. That means as you change the configuration of an object, it can regain back to its original position. But in case of plastic region, suppose if we extend the plasticity of that is extend the configuration of an object from this point to point E, it will never regain back to its original position. That is, relation is given by the materials which is under 10. So we have from A to B, it's called as proportional limit. That is, from point A is called as proportional limit. Point B, it is called as yield point or a elastic limit, after which if you just extend the configuration or change the configuration of any object, it will just change permanently. And as you, so elastic region, Hooke's law is obeyed. But as you start changing the configuration and reach up till D and E, finally we end up with the fracture point, that is, finally it will start breaking. Okay, so you can say that the stress is not directly proportional to strain in this point, because even if you give a small amount of stress also, the strain is greater than the stress because the strain is permanent there. Okay, so that is why it will undergo fracture point, it breaks down. Okay, so next we are checking on to elastic moduli. The proportionality constant in Hooke's law is called as modulus of elasticity. Okay, so proportionality constant can be called as K, as you have stress is directly proportional to strain in case of Hooke's law. So when you remove the proportionality constant, stress is equal to K into strain. This is called as modulus of elasticity. So now, depending on the type of stress applied, there are three types of modulus of elasticity. One is Young's, Bulk's, and shear modulus. So let us see much more about it. We have Young's modulus, that means it is given in terms of Y. Young's modulus is nothing but ratio of longitudinal stress. Longitudinal stress has got F by A itself to the longitudinal strain, which means to say change in length to original length. So ratio of longitudinal stress to longitudinal strain. So we have Y is equal to FL by A delta L. So this is your modulus of elasticity. You can just see how exactly is. Whenever a stress is produced of this value, strain is observed. That the same thing is what I have written over here. So you can see here. Next is shear modulus. Shear modulus, you have the length. So it's the same thing. Tangential thing is what you can actually see here. Tangential stress to shearing strain. So tangential stress is given as force per unit area. Shearing strain is given with respect to theta is equal to delta L by L with respect to the length, change in its length itself. So shear modulus is given in terms of eta. So sigma is equal to F by A. Eta, when you go with respect to this, you have sigma by theta. So what is sigma? It is F by A into delta L by L. It's the same thing as with respect to the Young's modulus. So both are also the same concepts. Next you have bulk modulus. So it is defined as hydraulic stress to the volume strain. Same thing is what we had discussed here in the previous, that is stress, types of stress also. So here hydraulic stress. So hydraulic stress, in this, it is given in terms of F by A, and volume strain is given in terms of delta V by V. So hydraulic stress can be determined with the bulk modulus, that bulk modulus is equal to F by A into delta V by V. So this is all about your hydraulic stress as well. So you can even write this as bulk force per unit area will be pressure divided by delta V by V. This can also be the equation. Accordingly, you can go with it. So this is all about your bulk modulus. Next, we are going to Poisson's ratio. So as you can see, there is a longitudinal strain which is happening over here, and lateral strain is happening with respect to its width. Okay. So what is Poisson's ratio? It is lateral strain to a longitudinal strain is what actually we study in this Poisson's ratio. This is one of the most important. So within the elastic limit, the ratio of lateral strain to longitudinal strain is known as your Poisson's ratio, one of the important laws. Next, we have elastic energy. What is meant by elastic energy? As you can see here, when a wire is stretched, that means that some work is done against the internal restoring force. Okay, it is done against the force. This work done appears as elastic potential energy. Just before it gets shooted up, there is a potential energy which has been happening over here, applied over here. Okay, so such kind of energy is called as elastic energy. So in today's class, we have studied the chapter that is mechanical properties of solids. Let us all meet in our next upcoming classes. Until then, have a good day. Thank you.